Today we are going to be converting a recurring decimal to a fraction. This is an AA style topic, so it only comes up in higher tier. So we're going to start by just recapping what a recurring decimal is. So a recurring decimal is a number which keeps repeating forever after the decimal point. So we use the dot notation above the number, and this shows us which number occurs. So for example, a lot of you may recognise this 0.3 recurring. So notice the dot is on top of the 3 here. So all this number means is that 0.333, and it's the 3 that repeats on forever. On the second one, 0.16 recurring. So the dot is only on this 6 here. So this decimal would look like 0.1, and then it's the 6 that repeats on and on. Okay, so it would be 0.1666, so we say 0.16 recurring. This 0.27, now you can see you've got two dots, one on top of the 2 and one on top of the 7. So it means those two numbers repeat in a pattern. So this decimal is going to look like 0.272727, etc. And finally, 0.512. So you can see you've got a dot on the 5 and you've got a dot on the 2. So the dots go on the first and the last number of the pattern. So the 512 is going to repeat on and on and on. So for example, 0.51251251251, etc. Okay, so all recurring decimals can actually be written as exact fractions, and we use an algebra equation method for this. So our examples: express the following recurring decimals as fractions in their simplest form. So we're going to start with number 1, 0.8 recurring. So we know this decimal is actually 0.8888, and it'll go on forever. So first of all, we're going to let x equal that 0.8 recurring. Okay, we actually write it out a little bit so it gets us understanding the process properly. Okay, so we're going to let x equals that 0.8 recurring. Now what we need to do is we need to multiply this decimal and the x by something to make sure that we still have the 8 recurring after the decimal point, but it changes a little bit in front of the point, so we no longer have 0. So for example, if we multiply both of these by 10, so if I times the x by 10 and if I times this decimal by 10, this is going to give us now 8.8 recurring. But it's now 10x. Okay, so 10x is going to be 8.8 recurring. Now what we do is we subtract the 2. So we take the 10x equals 8.8 recurring, and we take our x is 0.8 recurring, and like I said, we subtract the 2. And the reason why we want to do this is to get rid of the recurring part of the decimal. That's the whole point of it. We don't want that recurring part still there, so when we subtract them, it's going to disappear. That's the reason for multiplying the recurring decimal at the beginning by something, so that we can get rid of the recurring decimal. And this subtraction is a bit like when we did simultaneous equations. So you want to subtract this side as well. So you do 10x take away x. Remember, this is like 1x, so 10x take away 1x is 9x. Keep your equals there. And then we've got 8.8 recurring, take away 0.8 recurring. So these 8 recurrings are going to disappear, and 8 take away 0 is 8. So it leaves us with 9x equals 8. Now our last step, rearranging equations, we want to get rid of that 9, so divide by 9 to both sides. X equals 8 over 9. Obviously we want it written as a fraction, as we are expressing recurring decimals as fractions. And 8 over 9 is in its simplest form. Second one then, so we've got 0.31 recurring with the 3, 1 both got dots on it. So remember, this is like 3, 1, 3, 1, 3, 1. So first of all, we're going to let x equals 0.313131, etc. We often write it out just so we get the feel of what the decimal looks like. Now again, we need to multiply this by something, both sides of the equation, so that we still have the recurring decimal as 313131 after the point. So instead of timesing by 10 this time, we're going to times by 100, because then we're going to have it starting with 3, 1, 3, 1, instead of starting with that 1. So when we subtract the recurring decimals, they're going to disappear. So we're going to times both by 100 now. So it's going to give us 100x. Remember, you've got to do both sides of the equation. And this time, times it by 100 is going to give us 31.3131, etc. Okay, now we want to subtract the 2. Always the bigger one on the top. So 100x equals 31.3131, etc. The x equals 0.3131, and lay it out so that your units are in the correct places and your place value is lined up correctly, just to make it easier for yourself. So you have 100x, take away x first to give you 99x, equals, start this side, so obviously your recurring decimals, 3131, take away 3131, it's going to disappear. So you just have 31 take away 0 to give you 31. And then the final step, we want to get rid of that 99. So divide by 99 to both sides. X is 31 over 99. 31 is a prime number, so it cannot be simplified any further. Number 3 then, so we've got a longer pattern of numbers this time. So if you think about what I said at the beginning, this is going to be like 0.837, 837, 837, etc. So again, we're going to let x equal 0.837, 837, etc. Again, we need to multiply it by something so that after that decimal point we start with that 8 again to begin. So it should be 837, etc. So this time we need to multiply it by 1000. So we're going to multiply both sides of the equation by 1000. So it gives us 1000x equals 837.837, 837, etc. Because remember, that carries on forever as it's recurring. Again, we want to subtract now. So the 1000x goes on the top, equals that 837.837 recurring. And our x equals, and remember, lay your place value out, so 0.837837 underneath. Subtract them. So we've got 1000x, take away x to give us 999x. We've got 837.837 recurring, take away 0.837 recurring. So again, these are going to cancel, and 837 take away 0 is 837. Again, divide through now, so get rid of that 999. So divide by 999 to both sides. We get x equals 837 over 999. However, this fraction does simplify. Always try and check, okay? So obviously 999, you can see 3 will go into that. Remember our trick with our 3's. So if we add up the digits on the top, so 8 add 3 add 7 gives us 18, and 18 is in the 3 times table, so 3 will fit into it. So we're going to divide it by 3, okay? If you need to do a bus stop for your 837, divided by 3, 3 into 8 goes twice, carry 2, into 23 it goes 7, carry 2, and into 27 it goes 9. So you have 279, and then 999 divided by 3, 333. Again, we know 3 will go into 333. If you look at that 279, you can see the 27 and the 9, so 3 will go in again. So it goes into 27 9 times, and it goes into the 9 3 times, and into 333 1 1 1. So you get 93 over 111, and it will actually go down again. 3 goes into 93, and if you think about a trick, 1 add 1 add 1 is 3, which is in the 3 times table. So divide by 3, so 3 into 93 goes 31, and into 111, if you need to, another bus stop. So 1, 1, 1, 3 on the outside, into 1, it doesn't go, into 11, 3 times carry 2, and into 21, 7. So 37 on the denominator. 31 is prime, so we know that it can't be simplified any further. Number 4 then, so you've got 0.426 recurring. Notice the recurring dots are only on this 26. So this one is slightly different now because it's not all of the numbers that have got the recurring notation on. So again, we're going to let x equals 0.4262626. Remember, it is only the 2 and the 6 that recurs, not the 4 at the front. So we want to get just the recurring decimal at the end this time. Okay, so to start with, we can just times it by 10, and then you'll get that 26 on the end. So if we times both sides by 10, so 10x equals 4.2626, etc. But if we subtracted these, that 4 in the tenths and that 2 in the tenths is not going to subtract to 0. So we actually want to multiply this x equals 0.42626 again by something different to make sure we just have our recurring decimal after that point as 2626, etc. so that when we subtract it will disappear. So we want to multiply this again here. So if we multiply it by 1,000, you will see that it starts then with 2626, which is what we want. So we're also going to times it by 1,000. So 1,000x is going to give us 426.2626. Okay, and now when we subtract, because when we subtract we want to get rid of this recurring decimal, we're going to subtract these two. We're not going to use our x equals on this one, and we're going to use our 1,000x and our 10x. Remember, put the bigger one on the top, so we're going to have 1,000x equals 426.2626. And underneath we're going to have 10x equals, remember your place value, 4.2626, etc. And subtract them. So we have 1,000x, take away 10x first to give us 990x. And then here, remember, the whole point is so these recurring decimals will subtract, so these will cancel, and then we need to subtract these. So we have 426 take away 4. So 6 take away 4 gives you 2, and then 2 take away nothing, 4 take away nothing, so 422. So you've got 990x equals 422. Divide through by 990. It gives you x equals 422 over 990. Simplify now, you can see both of these are even. So if we halve it to start, half of 422, nice and easily, 211, and then half of 990, 495. Remember, if you're not good at your mental maths, bus stop everything. 211 won't simplify any further, so we can't cancel it down any further, so that's in its simplest form. Last example then, so very similar to the one before, just because it's slightly harder and slightly different. So we've got 0.372 recurring. So let x equals 0.37272. Picture what the decimal looks like. It will help you. Again, we want to multiply it so that it's just the decimal numbers that recur that goes after the point. So we want this 72 starting straight after the point. So if we multiply it by 10 first, 10x equals 3.7272. But this time now, notice we've got that 7272 in place. We need to do it again so that there's another number there that's got 7272 after the point. So this time I'm going to multiply it by 1,000. So 1,000x equals 372.7272, etc. Okay, remember we want to subtract, so the bigger one on the top, subtract the smaller one. So 1,000x again equals 372.7272. 10x equals, remember your place value, 3.7272. and we're going to subtract the 2. So again, 1000x take away 10x gives us 990x. We have the 7272 recurring decimals cancel, and then we have 372 take away 3, which gives us 369. Divide through by that 990 to get your x on its own. So divide by 990 to both sides. X equals 369 over 990. Again, you can see 3 goes into both here as 369 on the top, 99 with a 0 underneath. So if we divide by 3, 3 is very common in these, so always look for your 3's. So we have 1, 2, 3 when dividing by 3 on the top, and 330 underneath. Again, use your trick if you need to. So 1, you can see a 12 and 3, or 1 add 2 add 3 is 6. It's in the 3 times table. It can go down again. So we know 3 goes into 12 4 times, and into the 3 once. And then this one will go down as well, so into 33, 11, and that's 0. So it gives us 41 over 110, and 41 is a prime number, so it can't be simplified any further.